Hey there everyone, Mr. Roth here, and let's take a look at our very first theorem in honors geometry for the year. So this is a problem from your textbook. It asks you to prove that a pair of vertical angles are congruent. So how do we go about proving this beyond a shadow of a doubt? Not just for some specific value of an angle, but for any pair of vertical angles that we could possibly see. It's always good when setting up a proof to start by figuring out what it is we want to show. So we're given this figure here, and we know that what we want ultimately is to prove that the measure of angle MPN, this guy, is equal to the measure of angle LPO, that guy. So we know that the final conclusion of our proof is going to be this exact statement. So how to set up a proof? Commonly in this class we're going to use what's called a two-column proof. So we'll set up a table, and on the left side of our table will be a series of statements. On the right side of our table will be reasons that justify this statement. Initially, we're always given something, and in this case, we're just given what's in the figure. So we don't really need to write anything special about that. We don't know any measures. If you really want to say the given conditions of the problem, you could just say something like see figure to tell us that this is what we're working with. But in future proofs, there might be some more elaborate details here. For right now, there's no information other than the fact that we have a pair of intersecting lines creating these vertical angles that we know. So how are we going to prove that the measure of angle MPN is equal to the measure of angle LPO? Well, we know something about straight angles, right? We know that two angles that together form a straight angle are supplementary. They have to equal 180 degrees. So we notice that angle MPN together with angle MPL forms a straight angle. Since it's a straight angle, they must be supplementary. Their sum has to be 180 degrees. So we can write down that statement. The measure of angle MPN plus the measure of angle MPL must equal 180 degrees. Why is this true? Well, because these two angles form a straight angle. So we'll say definition of straight angle. But we also know that angle LPO forms a straight angle with angle LPM. So let's write that fact down. Measure of angle LPO plus measure of angle MPL equals 180 degrees. Why? Well, the same reason, definition of straight angle. I'll just abbreviate with ditto marks because I'm lazy. So we know that ultimately we want an equation that involves the measure of angle MPN, the measure of angle LPO. Currently, we have two equations that refer to those exact angles. And we notice that the rest of them are the same. There's a number of ways to do this, but I see that this expression, this sum of two angles, is equal to 180 degrees. Likewise, this expression is also equal to 180 degrees. Well, if these are equal to the same thing, then they themselves must be equal. So I'm going to write down that the measure of angle MPN plus the measure of angle MPL must equal the measure of angle LPO plus the measure of angle MPL. Why is this true? Well, it's an important fact from algebra called the transitive property of equality. Transitive property of equality, which essentially says if A equals B and B equals C, then A and C must be equal to each other. We're almost done. We almost have the desired statement. We notice that on each side of this equation, there's something common, right? There's this measure of angle MPL. So we can do basic algebra, subtracting the same thing from both sides, respecting the golden rule, to finally conclude that the measure of angle MPN is equal to the measure of angle LPO. Our reason for this was simply, I like to refer to this as the golden rule of algebra, so we can write that down as our reason. Golden rule of algebra. Technically, it's the subtraction property of equality, but I don't think we need to get any more detailed than that. So we started what was given, not too much in our figure. We proceeded with logical steps justified by reasons, and we finish with the desired conclusion. So we can say Q, E, D, or if you prefer, you can use the little Halma symbol. Notation's up to you. Thanks for watching.